Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at Organic Chemistry 1, and specifically, we are going to be looking at the naming of alkynes. So, in our previous lesson, we were looking at the nomenclature of alkynes. So, for this lesson, we are going to look at the rules we use when we are naming alkynes, and then we're going to practice a few questions. So first, one of the rules of naming alkynes, we identify the longest continuous chain, which contains the triple bond, which determines the parent name. So just like we said in alkenes, the longest chain must include the double bond. So in this case, also the longest chain must have a triple bond. And then the moment we identify where the triple bond and the longest chain is, we number the number of carbons, giving the triple bond the least possible number. So our preference is on the triple bond. So for example, if you look at this compound, so let's identify the longest chain. So 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. So we are going to pick our longest chain as this. It looks crooked, but it's continuous. There's no breaking that is happening. So this is our chain that contains the double bond. So when we start naming, we need to give the triple bond, the least possible number. So you notice whichever direction you use, the triple bond will always have the same number. So we can decide to name from 1, 2, 3, 4, 5, 6, 7, 8. Because if you name it the other way around, it's still going to be at carbon number 4. Second, let's look at this. So you can see this is a skeletal formula. So when we are naming, the one that is in red must be the longest chain because you can see the triple bond must be part of it. So this is the longest chain as you can see, and the same case even in the second image. So numbering we must give the triple bond the least possible number. So definitely this is going to be preferred because numbering starts from where the triple bond is. So we prefer this to this. Another example is this. You know that the triple bond must be in the longest chain. So you start counting from here 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is going to be our longest chain. It's continuous, as you can see. So anything outside of it, this is a chloride, iodide, and then methyl is a branch. So we start naming it from this side so that we can give the triple bond carbon number 2. Next is now we indicate the positions by splitting the alk and ine but sasa in this case you are going to be given the position of the triple bond. So for example, since we already identified this as the longest chain and we numbered it 1, 2, 3, 4, 5, 6, 7, 8. So you see the triple bond is in carbon number 8. So the longest chain is an oct, but now the triple bond is in carbon number 4 and then iron, like we were doing in alkenes, but in this case it becomes iron. So for this case, remember we said we are not using this. So this becomes, it becomes oct as well, then 1 iron, because the triple bond is in the first carbon, which is number 1. This one becomes in carbon number 2. Remember this carbon says 1, number 2, and number 3, but we tick the list. So this becomes non, then 2 iron, because it's in carbon number 2. And then after that, we determine the position and the number of and the type of branches present. So after giving the triple bond the preference, after that now we start naming the branches. And remember when we are naming, we name them alphabetically. So for example, in our example that also we were still using, let's try to name this. Remember this is in carbon number 4. 5, 6, 7, 8. So we have a branch here called methyl. We have another branch also called methyl. So the first branch is in carbon number 3, the other one is in carbon number 6, and they are the same type. So one methyl is in carbon number 3, the other one is in carbon number 6, and since there are two, we will call them dimethyl. And then the parent name is oct, and the triple bond is in carbon number 4, ion, like that. So remember, we're not using this. So this becomes, there's a branch here and there's a branch here because the red one is the longest chain. So this branch is called 1, 2, 3. This branch is propyl, and this one is methyl. So when you look at alphabetically, we start with the methyl. So methyl is carbon number 7, so it becomes 7 methyl. And then propyl is in carbon number 3. That is 1, 1, 2. It's carbon number 3. 3 propyl. Parent name is 8 carbon, so it's oct. And then carbon number 1, ion, as we did before. And then let's name this. So we have a chloro, iodo, and a methyl. So when you look at chloro, iodo, and methyl, when we start naming, we start with chloro, then iodo, and then methyl. So chloro is in carbon number 4, so it becomes 4-chloro. And then the iodines are both in number 6, so it becomes one of them is number 6, the other one is number 6. And since they are similar, it becomes diiodo. And then there is a methyl, 7-methyl. Parent name, which is non. And then the triple bond is in carbon number 2, so it becomes 2-9. So that's how you name using the branches. That's how you name alkynes as well. So we do a few questions. So we have this. So the longest chain is going to be this, and you number from this side 1, 2, 3, 4, 5, 6. So the triple bond is going to be in carbon number 3. We have a methyl here and a methyl. So it's going to be, both of them are in carbon number 2, so it's 2, 2-dimethyl. And the parent name is 6 carbon, so it's X. And then the triple bond is in carbon number 3, ion. This one is having 2 triple bonds. We said, just like we said in alkenes, when we have more than 2, we just add a di at the last, at the parent name. So this is 1, 2, 3, 4, 5, 6, 7, 8. If we number the other way, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So the upper one, the first triple bond is in number 2, the second is in number 5. The second way of calculating the first triple bond is in number 3, the second is in number 6. So we prefer the upper one. So it's going to be oct. The first triple bond is in number 2, the second triple bond is number 5, and since there are two, we call it diene. So it's oct-2,5-diene. So let's look at this one. So the longest chain is going to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So if you pick this one, it's the easiest. So this is a ethyl. This one is an ethyl as well, branch. This one is a methyl. So we will start numbering from 1, 2, 3, 4. 1, 2, 3, 4. So either way, we are still going to get the same. So we start numbering from this side so that you can give the branches the list. 2, 3, 4, 5, 6, 7, 8. So we have when you start numbering, we start with ethyl. We have one ethyl at carbon number 3, the second one at carbon number 6, so it becomes diethyl. And then we have a methyl at carbon number 2. The parent name is oct. We have a triple bond at carbon number 4, fine. So let's do a bit of some drawing. So name and draw out the following molecules. So we have 4,4-dimethyl pentane. So we start with the parent name. It's pentane with a triple bond at carbon number 2. So there are 5 carbons. And then carbon number 2, that is where we have the triple bond. And then we have a methyl at carbon number 4. Note it says that the triple bond is in carbon number 2, just like we had placed. So when you start naming, you name one, you count 1, 2, 3, and then we have a methyl at carbon number 4. So you put the methyl, and that's it. The rest now are hydrogen. Make sure you count each carbon should be enough. This is 1, 2, 3, 4, so nothing there. 1, 2, 3, 4, nothing there. So hydrogen and hydrogen and hydrogen. And then 4 pentyne, 1 ine, so 5 as well, like that. So we have a triple bond at carbon number 1, so the rest are hydrogens. And finally, we have nonine, and this nonine, we have a methyl, 2 of them at carbon number 3 and 1 ethyl at carbon number 1. I think there is an error in the last one because we shouldn't have an ethyl in the first carbon. It changes the longest chain. So we are going to leave it at that. That's how we usually write or draw structures of alkynes. I'll see you in the next lesson as we look at isomerism.